We heard that some of you couldn't hear us, and we apologize for any inconvenience. That speech was both inspiring and encouraging to hear focus on the leading economy to ramp up the production and deployment of hydrogen and creating a global market to accelerate decarbonization of industry. But let's move back to the session. As Dolph mentioned, under normal circumstances, we would have met in person, as was the case in our previous IRENA Innovation Week editions in 2016 and 2018. But a virtual event has its benefits too. We can connect from anywhere in the world. And in fact, we have over 2,000 registered attendees for the whole week of discussions who are coming from 146 different countries. Our speakers also come from many different continents, and they are ready to showcase their experiences and emerging innovative solutions they can fully unlock renewables potential in industry and transport sector. In the past 3 days, we discussed supply side of the energy transition equation. Today, we kick off the demand side, and we'll start with the use of electricity, hydrogen, e-fuels, and biofuels and biomass use in industry. IRENA is organizing this session in partnership with the World Economic Forum Mission Possible platform. World Economic Forum is the international, independent, and impartial institution for public-private cooperation. They focus on connecting communities of leaders around global issues through high-level meetings, research initiatives, and digital networks. The topic IRENA and WEF brings you today is highly relevant. As to hold temperature rise at no more than 1.5 degrees requires deep decarbonization in every sector, and showcasing the most promising technology-driven innovations for energy and carbon-intensive industries around the world will bring confidence in advancing this work. We will focus on iron and steel, cement and chemical sectors, and expert will show what is possible now, and we'll explore how to accelerate the development and dissemination of innovative solutions. But before I dive into the agenda for today, let me reiterate some of the housekeeping items mentioned by Dolph. So all of you are muted, and you will remain so throughout the event. However, there is a Q&A section, and we invite you to pose questions to our panelists there. So please mention which panel discussion or the panelists your questions relate to. We will be monitoring these questions throughout the event and select a few. Due to time constraints, we apologize in advance if your question is not answered, and we will use all questions to inform our further discussions. You can also use the same function to introduce yourself and let us know where you tune from. This is the public event. It is being recorded and live streamed. The recording will be available on demand in a public domain on Innovation Week IRENA website. Please know, therefore, that Chatham House rules do not apply to these discussions. For the agenda today, the agenda today will be structured as follows. We heard from Dolph Gilland his welcoming remarks. Up next are 3 speeches from Anthony Hobley, Executive Director of the Mission Possible platform at the World Economic Forum, followed by Claire O'Neill, Managing Director of the Climate and Energy at World Business Council for Sustainable Development. And we will finish the scene setting part with Paul Duron, Senior Program Officer and Head of End Use sector and bioenergy, and IRENA, who will all set the scenes for the following panel discussions. And then we will dive deeper into panel discussions, and we will discuss solutions in the first panel on iron and steel, in the second panel on cement and lime, and in the third panel on chemical and petrochemical sectors. And in the closing remark, Dr. Dolph Gilland from IRENA will briefly recap and wrap up the sessions with key takeaways. So without any further ado, let's move right to the scene setting part. And it is my pleasure to introduce you to Anthony Hobley, Executive Director of the Mission Possible platform at World Economic Forum. Anthony, please, the floor is yours.
Thank you. Good morning, everybody. Good afternoon, good evening, depending on which part of the world you're in. Thank you so much to IRENA for the opportunity to contribute to IRENA's Innovation Week and to speak to this important session on renewable solutions for the industry sector transformation. I'm just waiting for the slides to come up on the screen. Wonderful. From the Forum and Mission Possible side, we're very pleased to co-host this day together with IRENA. We're also proud that we last month signed an MOU between the World Economic Forum and IRENA to work more closely together, deepening our cooperation on accelerating bold action for industry and the energy transition. Today, I'm going to focus my remarks on a bit of context for our meeting today. So the intersection between the energy and the industry transition, and what needs to be done ahead of COP26 to move forward on delivering sectoral industry transition agreements. So if we can go to the next slide, please. I think we really know that the COVID pandemic has created a new context, a new reality, if you like. It presents us with both opportunities and risks. So we have the opportunity for a great reset and a more resilient and sustainable society. But we also have the risk of a great lock-in of climate tipping points. And I think we know that winning slowly is the same as losing. There is a lot of great work that we're all doing, but it's incredibly important that we bring this together in a coherent way so we accelerate the transition. This is a decisive decade. We need to raise ambition, and if we can have the next slide, please, and we need to translate that ambition into action. So within the World Economic Forum, we think about the 3 A's. A for ambition, so setting ambitious targets and commitments. We issued a challenge, a net zero challenge to all of our members in January. So for 1,000 companies to take on net zero commitments over the next 3 years. And we were pushing that ambition incredibly hard over the coming 2 years. But ambition it doesn't really count unless we can convert that ambition into action. So that is our second A. So implementing concrete and measurable net zero pathways. And in the context of our work with Mission Possible, that means working with industry to, in a sense, negotiate and agree the right technological pathways to get us to net zero by 2050. And our third A is alignment. So working across the forum and all of our initiatives to build a net zero climate aligned economy. We'll have the next slide, please. The Mission Possible platform and the intersection between industry and the energy transition is critical. But we also need to understand as we move towards COP26 that the economy is not a side event. And for any of those who have been to the COPs, the international climate negotiations, over the years, you will understand what I mean. We need to put the real economy on a par with the international negotiations so that the two are mutually reinforcing. And I think that's a critical part of our work over the next year as we move towards COP26. Let me say a few words about the intersection between the industry transition and the energy transition. We go to the next slide, please. Almost 1 year ago, in 2019, the UN Climate Summit, the forum together with the Energy Transitions Commission launched the Mission Possible platform, focusing on a sectoral approach to how we decarbonize 7 of the most energy intensive industrial sectors, the transport sectors and the material sectors. So shipping, aviation, heavy trucking, steel, aluminium, cement, chemicals. We started with 30 plus companies. In the last year, across our initiatives, that has now grown to over 300 companies who want to be part of this ambitious transition. Because I think we all understand that business doesn't stop at the border and neither do emissions. So industry has to work together in support of the process across borders, across supply chains. If we can go to the next slide. Because when you scratch the surface of any national economy, you find sectors, and those sectors are linked up through supply chains. So we have this vision working with many of our partners, such as WBCSD, and it's wonderful to have Claire also on the panel, where we can work with industry over the next 14 months to knit together a sectoral approach that will support the international approach within the UNFCCC framework, and help governments, give governments the room, if you like, to be more ambitious. Because if their industries, or a significant proportion of their industries can be ambitious, so can governments. So the key message, if we can go to the next slide, please, from Mission Possible and the work we're doing and the report that underlays much of our work, prepared by our partners, the Energy Transitions Commission, is that we have the technologies. It is technically and economically possible to achieve net zero emissions by mid-century. Technologies and business solutions, are either available or they are ready to be scaled. Economically, there is a cost to the economy, but it is at a global level, it is relatively small, at 0.5% of global GDP. But also, it is quite clear as we scale those technologies, as we've already seen in many other technologies, wind, solar, batteries, electric vehicles, those costs come down. Those costs come down until they're comparable, if not cheaper, than business as usual technologies. And that is our challenge over the next 30 years as we move towards 2050. If we have the next slide, please. However, I would add one third dimension to this. If we're to achieve the transition to net zero of these 7 harder to abate sectors, the backbone of the global economy, we need a profound transformation of our energy system. If we can go to the next slide, please. We need a 3-pronged strategy for energy transition. And this is set out again in our partner, the Energy Transitions Commission's new report, Making Mission Possible. We need clean energy and hydrogen anywhere we can. We need to drive massive clean electrification of buildings, transport and industry. We need to use hydrogen where we can't electrify. We need to decarbonize the remaining energy using CCS and sustainable bioenergy. We need to significantly scale up clean energy provision. So we need to multiply current electricity generation by 10 to 15 times. We need to scale up zero carbon hydrogen production to reach 700 to 1,000 metric tons per annum. We need to build biofuel and synthetic fuel supply chains. And of course, we need to use less energy. The cheapest energy of all is energy efficiency, as we know. We need to see a 5-fold increase in power generation to meet this transition. And this is feasible. This is a feasible path to net zero economy. And our modeling shows that the Paris Agreement climate objectives can be met with this scaling up from around 20,000 terawatt hours today to between 86 and 115,000 by mid-century. If we can go to the next slide, please. And one of the ways we can do this is we can work across the supply chains, industry, the suppliers, customers, governments, and the financial institutions to create a flywheel of progress. We can work within the countries that are ready for this transformation. We can prove that this works by working with industry on systems demonstration. Governments can follow that with the right policy and support mechanisms, as we heard from the German minister. And that eventually sets up a virtuous flywheel where the transition becomes sustainable. We have seen this over the last 20 or 30 years with renewable energy to get to the cost position that renewables is now cheaper than coal power generation, for example. We need to replicate that, but at a much faster speed across the harder sector. Can we go to the next slide, please? We've looked across all of these sectors and we've learned a lot of lessons from the transitions that are already underway in energy, in renewables, but also in shipping, aviation and steel and some other sectors. And we've got a replicable 4-step approach that can be tailored across these 7 sectors. And again, we are working with many partners in government, in the civil society, across NGOs, and across the 300 companies that we're working with to implement this 4-step approach and all of the elements within it to accelerate that transition and create that flywheel. If we can go to the next slide, please. So there isn't a next slide. We cut that one out. But just to conclude, we're absolutely convinced that reaching net zero by 2050 is possible, but it won't be achievable if we work in silos. We need to put the problem at the center with the institutions and the companies, and we need to work in a joined up fashion to deliver real results. And COP26 is a moment in time where we can either deliver or kick off a process for sectoral agreements across these 7 sectors. I'm incredibly encouraged to see many of the distinguished representatives from industry, business and government with us today, and part of IRENA's Innovation Week. And I look forward to an impactful discussion to continuing our work together. Thank you.
Thank you, Anthony, very much for your encouraging messages, and indeed challenging period ahead of us, but solutions are there, and the pathway is quite clear. So we just have to accelerate our efforts. Thank you very much. And next is Claire O'Neill, Managing Director of Climate and Energy at the World Business Council for Sustainable Development. Claire, over to you.
Well, thank you very much, and good everyone who's watching. Pleasure to be with you all again. Before I joined WBCSD, I was the UK Minister for Energy and Clean Growth, responsible for bringing in the net zero legislation and also for attracting the COP26 to the UK. So I wanted to share with you some perspectives from that experience, but also to start by really thanking you as an organisation for focusing on what I often think is this forgotten part of the decarbonisation journey. When I was in the UK government, we talked a lot about homes emissions, clearly very important, but only 13% of emissions at that time. And of course, industrial emissions, which were about 25%, were often not really talked about because they are really tough to reduce. And as I think many of us will have heard Bill Gates say, when we talk about this net zero journey, we should be thinking now about 20%, the hard to abate sectors and processes that are out there. So I do really welcome this opportunity, and it's a pleasure to follow Anthony. WBCSD is a member-led organisation. Many of you have been on the global stage now for 25 years, and our mission is to help our members achieve solutions across the whole sustainability spectrum. And I wanted to perhaps a really important process, transition and really revolution that has happened in the energy sector, because I think it has really important insights for trying to achieve. So many of you will, if you are watchers of UK politics, will have seen the announcement yesterday that the UK government is very substantial expectations for the contribution of offshore wind power to our national grid, now looking at numbers of 40 gigawatts over the next few years. And to share with you, because I think there are important lessons. When I published the Clean Growth Strategy for the UK back in 2017, which really set out pathways right across the economy, there was a question as to how much offshore wind could really be in the mix. Clearly, there's an enormous geographic advantage for countries around the North Sea to be using offshore wind. But at that point, we were forecasting no more than 10 gigawatts. And of course, the question there was, what was the cost and how were we going to get costs down? And those of you who are real energy geeks will know that we were sourcing offshore wind at about £150 per megawatt hour only a few years ago. But we did a thing that involved an extraordinary amount of collaboration with industry and with government. We put together a sector deal that essentially set out, using an auction structure, what both parties could expect, how much energy we would want to buy, what investments we would make in terms of innovation, and also we set out some other targets like some workforce goals as well, because clearly skills transfer are questions in these transformations. And the results were enormously startling, actually. The price that we were able to purchase offshore wind at auction dropped from £156 per megawatt hour to under £40 in just a matter of 18 months, making it competitive with new gas generation on the grid. And I think the lessons from that are really applicable to this question of how we actually decarbonise using renewables, the highest heat, hardest to decarbonise industrial sectors. And there were 3 takeaways actually for me. Support. It was really impressive to hear State Secretary Feith talk about German realisation of the need to support with policy signals the development of hydrogen, getting ultimately to green hydrogen. And I think that sense, if we have politicians on the call today, that sense of policy support looks, there's an element of subsidy in that, because we know we have to get these technologies into the money, but there is also an element of what other things need to happen. Often it's just visibility of support, which of course persuades investors sector that there is a stability, if you like, to the forecasts that are being put forward. The second is the contractual structure. I mean, I think the auction structure that was introduced in the UK has been incredibly interesting at a government level for pulling forward continued downward pressure on costs and continued upward contribution of innovation. And we've seen actually in the power sector that innovation, that contract structure being taken through to the corporate level using power purchase agreements. One of the things the WBCSD does with members is focus on the how. We know what we need to do, but how do we actually do this? And one of our big programs has been working with our members to really develop innovative PPAs, which I think from which we could learn a lot for pulling forward these high heat decarbonisation technologies. And then the third question, or the third important point, is this sense of the integration, not just of who needs to be in the value chain, but the infrastructure that underpins these transformations. Just to take the offshore wind case, we tend to structure offshore wind contracts on a point-to-point basis, i.e. the developer had the responsibility of bringing that wind back to the onshore grid. Of course, the thing that energy supply really needs is an offshore connection, an offshore ring main, if you like. And now that understanding of what infrastructure needs to be in place and crucially who will fund it, I think is absolutely integral to these transformations. The same with CCUS. When I set up the CCUS task force, we did a huge amount of work on this. We've continued to innovate, but actually the CCUS question is really, for me, an infrastructure question. Who pays for the infrastructure that underpins that collective capture, transmission and storage capabilities? And lots of work happening in that space and lots of innovation. And again, it was very encouraging to hear the German State Secretary talk about that realization, that understanding that embedding this integration into the conversations about hydrogen, trade deals, which very interestingly, but understanding this need to integrate, I think, is hugely important. And I am, completely convinced that what we do with renewable energy can be brought to bear on solutions for decarbonisation for industry. Obviously, we are all extremely focused on hydrogen, absolutely fascinating, where there is a scale up really for renewables, as we know. But as we start to build out these renewables, surely we can be integrating the hydrogen thinking into these renewable platforms. We now, of course, will be talking a lot about offshore wind from the UK, floating offshore wind, a fascinating technology, baking in the hydrogen conversation into that so that, I don't know, we could generate hydrogen in shipping lanes using floating offshore wind technology so that start to transform that hard to decarbonize sector, the shipping sector. And I just wanted to highlight, because as much as I love to talk about public-private interaction and the role of government, one of the reasons for coming to WBCSD is I am firmly convinced that the white heat of innovation it shines very strongly in the private sector, and we have companies and sectors who are prepared to innovate and prepared to collaborate and actually create these lighthouse projects. And I just wanted to flag a couple of projects amongst our member group that I think have really interesting lessons. So Iberdrola, as many of you will know, the amazing Spanish utility, they are pushing forward scaling up green hydrogen in Europe's largest electrolyzer and using the hydrogen generated in their ammonia and fertilization plants. So again, thinking about that integrated energy structure right at the local level. But we've also seen amazing collaboration. So we have, many of you will know, the gigawatt electrolyzer project, which is hundreds of times bigger than current electrolyzers, looking to push that out by by latest 2030. And that is a collaboration between a series of companies, the Port of Rotterdam, Shell, Dow, Yara, other stakeholders, including ports, universities in the provinces of the Netherlands, to really scale up that extraordinary renewables production of hydrogen. And I know we're going to hear a bit more about biogas later today, but again, we're seeing real innovation amongst these global companies, thinking about how they might use biogas, often as a waste product, and integrate it into their own generation system. So, I mean, just to close, thanks again for the opportunity to talk about what I think is sometimes the orphan child of the decarbonisation debate. You know, what's that last 20%? Let's think about that now. And for me, the three takeaway lessons from time in government and also now working with our member companies are the integration of policy structures with the private sector up front, getting together those sectors, you know, doing sector deals. Anthony referenced the great work that WEF is leading with many of us involved in trying to really push these sectors and the governments around them to think about this integrated level of activity going forward. The second is the innovation. Where can we innovate? Where can we have lighthouse projects? Where can we try? Where can we do at a small scale what we want to do at a large scale? And obviously also in innovation in the financial and contracting sense. I can't emphasize enough how much the contracting structure, and I'm not claiming it was a sort of, you know, UK breakthrough, but using auction really drive innovation in the financial structuring of our offshore industry has obviously been extremely helpful in getting these technologies to a cost position where they're so competitive. And lastly, infrastructure. If we are to transform the way that our businesses operate, we have to be thinking now about the boring stuff, the pipelines, the grid connections, the generation points. How are we going to create a new infrastructure setup that is no longer a point-to-point transmission system of fossil fuels, but is more decentralized, more integrated, and deals with those thorny questions of, frankly, who pays for the pipes and the wires. And I think we need to be focusing on solving those problems as well as the integration problems and the innovation problems that so many are committed to doing. But thanks so much for a chance to chat with everyone today.
Thank you. Thank you, Claire, for emphasizing a few words that keep repeating across sessions: integration, innovation, infrastructure, and collaboration. And thank you for sharing us the experiences to be replicated and lessons to be learned from, and focus not only on what, but also how we can do it better and more efficiently. Thank you very much. And we will conclude this scene setting part with Dr. Paul Durand from IRENA with his presentation. Paul, over to you.
Well, thank you very much, Martina, and thank you very much to both Anthony and Claire. I thought that was excellent introductions to our session. I really find I very much agree with the insights that you were sharing there. You framed the challenges and what we're trying to tackle and why we need to do so. I was particularly struck by the comparisons that Claire drew there with offshore wind, and I too agree that we can draw a lot of lessons from that experience and from some of the other technologies. I worked for the British government for 20 years and saw that journey up close and was involved in it. And you think back 12 years ago, offshore wind was treated with a lot of skepticism that it could ever be cost effective. But thanks to a lot of good work, here we are, and it's very much a mainstream technology. I think lessons from that and some optimism from that can be applied to the end-use sectors. So with my remarks, I kind of want to build on and perhaps dive into a little bit of detail on some of the sectors that are particularly hard to challenge. And in particular, I want to give you some highlights from IRENA's Reaching Zero with Renewables project and the report we published just 2 weeks ago, produced by my team. Next slide, please. Now, part of IRENA's role is to support our member countries in their energy transitions. So we look holistically at what is needed globally, regionally, and nationally. And over the course of several years now, we've developed a comprehensive data-based analytical framework to map the path to achieve Paris Climate Change Agreement goals. Earlier this year in April, we published an annual report, which we call this year the Global Renewables Outlook. And the focus of that report is on an emission reduction pathway compatible with the Paris Agreement's well below 2 degrees target. That 2 degree pathway, and you see it there in blue, looks challenging, but with the right support, it does look achievable. However, a growing number of countries, as indeed we heard earlier, are supporting a more ambitious goal to have the high likelihood of holding temperature rises to 1.5 degrees. So for the first time in our report, we looked at what was necessary to achieve that. We called it the deeper decarbonisation perspective. You see it there on the bottom. And the goal there was to reach zero emissions. Before I move on, one more thing I want to highlight from this slide is, you see at the top there, we've labelled something called the planned energy scenario. This comes up later in my presentation. The planned energy scenario is what we project would happen if we just continue with existing policies, including existing NDC commitments. It's a business as usual trajectory. Next slide, please. Now, achieving that ambitious target of 1.5 degrees will require a concerted effort to get very close to or achieve net zero CO2 emissions across all sectors of the economy by early in the second half of this century. Reaching that target is going to be challenging in all sectors, but in some cases we at least have a reasonably clear vision of how to do so. In the power sector, for example, the falling cost of renewables means that by 2050, over 80% of the power that we need could be sourced from renewables, our analysis suggests. We don't have similar clarity in some other sectors, and in particular, some aspects of industry and transport. These two already account for significant shares of emissions, and under current policies will grow, not shrink, by 2050. Now, within those broad sectors, there are some specific sectors that look particularly tricky. Anthony mentioned them in his presentation. There are 4 industry sectors and 3 transport sectors that will make up 38% of energy and process emissions and 43% of final energy use by 2050, unless we enact major policy changes. Next slide, please. So you see those 7 slides, 7 sectors up on the screen, and the numbers underneath are the state of them in 2017. High energy use, very low penetration of renewables, significant emissions. Now, there's been very little progress in these sectors over the last decade or two, but we see reasons for optimism that that can change, and in particular 2 conditions should enable faster progress. First, that strong and widening societal recognition and increasing political consensus on the need for all sectors to make deep cuts in carbon emissions, despite the challenges of doing so. And the second, the rapid decline in the cost of renewables over the past decade and the future potential for further cost reductions opens up options for the use of renewable energy that were previously dismissed. Next slide, please. And that's what our Reaching Zero report focused on. Published a couple of weeks ago, we look at the high potential for renewables use, much more than previous analysis has identified. Our assessment is the use of renewables, both for energy and feedstocks, could account for 54% of the economic emission abatement potential by 2050. Next slide, please. The report shows that the elimination of both energy and process emissions, and I emphasize both those points, in these sectors is built on 5 pillars. The starting point should be demand reduction, energy efficiency, particularly through circular economy approaches. We estimate that could account for 28% and 36% respectively in the industry and transport sectors that we've analysed. We see a major role for the direct electrification of renewables, circa 20% in both cases. In addition, the direct use of renewables, renewable heat, but in particular the use of biomass and biofuels could account for a further 16% of the reductions. Indirect electrification renewables, i.e. to produce green hydrogen and the onward production of synthetic e-fuels, could account for 10% in the industry sector, but a much larger share, 28% in the transport sector. Lastly, we do see a role for carbon removal technologies, in particular CCUS. But thanks to that larger role for renewables, our estimates are that the role of CCUS will be lower than perhaps others have estimated. I think circa 26% in the industry sector, and not a significant role in the transport sector. So, in principle, there's a range of options available to help reduce emissions. The goal of reaching, or at least coming close to zero, requires a very different mindset compared to the objective of merely reducing emissions. Next slide, please. Now, options that merely partially reduce emissions aren't enough, and at worst, risk diverting resources or locking in emissions if we focus on things that only partially drive down emissions. We need to be focusing on those options that are consistent with and will eventually get us to zero emissions. There are only a small number of those across the sector, as our report highlights, and most of those options are not yet sufficiently well proven or cost attractive to be clear-cut choices for the sector. The report explores those options in detail. Our upcoming panel sessions also will explore some of those options in detail, so I'm not going to get into it now. I just want to give you a little bit of a flavour of how stark our choices are. Now, let's take steel as one example. Now, there are lots of nuances, which we'll probably explore later, but to keep it big picture, various approaches are being researched. But if we look at what's credible to be scaled up in the timeframes that we have available to us, it essentially boils down to two choices. First is a renewables route. Either we switch to the so-called direct reduction of iron route, which is proven with natural gas, but can be converted to hydrogen, and then combined with electric arc furnaces, again powered by renewables, is a strategy for eliminating emissions in the steel. The alternative is we continue to use fossil fuel as the feedstock for the reduction agent, but we need to capture the emissions. Those are our choices. We go one route or the other. Everything else is just details. Next slide, please. The cement sector is even more complicated. There we don't have a single option that is consistent with zero emissions. We are going to need to use a combination of things. You see them on the screen. I won't walk you through all of it, but it's a combination of reducing demand for conventional cement, using renewables to eliminate the fossil fuel for energy use in cement production, trying to push down the process emissions from conventional cement by reducing the amount of clinker that is in cement mix. And for remaining emissions, we will need to apply CCS to at least some plants, but we might also be able to offset emissions from unabated plants through the use of negative emission technologies such as BECCS applied to CCS, or storage of CO2 in wood for construction, for example. Next slide, please. Same story applies to the chemical sector and aluminium. I won't unpack it here. I'll just finish by sharing a few thoughts on what are the priorities for action. And indeed, you heard some of this from Anthony and from Claire very eloquently. Next slide, please. We look at sector-specific actions, but looking across sector, there are a number of column elements. The starting point for action must be to build this shared vision and broad understanding across decision makers, public and private sector. What are the challenges? What are the opportunities? And to try and develop a consensus on the broad strokes of a plan to address them. Our analysis suggests a central feature of all sector plans should be to dramatically expand the use of renewables. We need to create viable business models. Particularly creating that early demand for green products and services will be critical to early progress. Sectors and countries cannot work in isolation. Partnership working between industry and government and across borders will be crucial. No one organisation, no one country has the resources or capability to solve these challenges alone. And lastly, innovation underpins it all. We have many of the tools we need, we have many of the solutions we need, but we don't have all of them, and they're not sufficiently mature and developed to be widely applied. Innovation is crucial in this sector. So in closing, last slide, please. We've made remarkable progress in the last decade in developing renewable energy sources for power production, and we now see a pathway forward for decarbonising power systems. We need to make comparable progress in addressing carbon emissions in the end-use sectors. And that transition, that 40 years transition, has barely begun, but it needs far more attention, greater planning, more ingenuity if we're going to deliver it in the timeframes available. Our assessment is that it's possible. With the right plans, sufficient support, the goal of reaching those zero emissions in key transport sector looks achievable. Really looking forward to the rest of this session, to the insightful discussions I'm sure that will follow, that will help us understand how we're going to do that. Many thanks for your attention.
Thank you, Paul, for sharing with us the key takeaways from the Reaching Zero with Renewables report. And thank you again, Anthony, Claire, and Paul, for setting the scenes for our upcoming discussions and what are the solutions, opportunities to accelerate the use of renewables in industry. Thank you very much. And now let's move to the first panel discussion. It is my pleasure to introduce you to the moderator of the first panel, Faustine de la Salle, Director of the Energy Transition Commission. But before I hand over it to Faustina, please don't forget to use Q&A feature to ask questions to our speakers. And now, Faustine, over to you.
Thank you very much. It's a pleasure to be with you this morning. I'm the Director of the Energy Transitions Commission, and the Energy Transitions Commission is a commission that brings together businesses from across the world working on energy, so a mix of energy providers, energy consumers, and finance players. And 2 years ago, we had published the first report on how to decarbonize harder to abate sectors. And I'm very glad to see now the IRENA really focusing on those topics as well and reaching conclusions that are very similar to those we had reached. Since then, we've been working with the World Economic Forum to progress the Mission Possible platform, named after the report we published in 2018. And we have in particular led the Net Zero Steel initiative that aims to bring together stakeholders from across the steel industry to work on how to reach net zero emissions across the iron and steel sector. So I'm particularly glad to be moderating this panel and to be welcoming in particular Eza Ekdal, Head of Environment and Climate Change at the World Steel Association, Andreas Regnell, Chairman of Hybrid, and Dr. Yongin Han, Senior Vice President, Management Consulting Center of POSCO's Research Institute. Thanks a lot to the two of you for joining us. I want to run through a couple of thoughts before turning to you. If we go on the next slide. We know, and that's what Paul just said, that there's a range of potential decarbonization technologies available for the steel industry. Some of them are only transitional options, and others can really enable us to reach net zero emissions. And each of those technologies, I won't go through the whole list, is currently at a different stage of development and deployment. So a panel of options, but obviously that panel of options creates uncertainty from a market and investment point of view. Next slide. Based on the analysis that we've done, and I think this is also the conclusion that IRENA is reaching, there doesn't appear to be a silver bullet, in the sense that the most cost-competitive decarbonization option will probably vary by region and by site, depending on local availability of resources, especially depending on the cost of zero carbon electricity locally, but also depending on whether the site is greenfield or brownfield, which also changes the dynamics and the cost comparison between different options and decarbonization options. Next slide. The key barrier, regardless of the technology option that you opt for, is that currently producing zero emission steel is more costly than producing normal steel. And that cost can be quite significant at a B2B level, even if it translates into a very small increase on prices to end consumers of objects and products made out of steel, for instance, of an automotive. So the key question in that context is, how do we, and I'm going to go to the next slide, really enable the next wave of investment in the steel industry to be low carbon and eventually zero carbon, despite the fact that the economics are not yet there to have and underpin a business case that would be a traditional business case for the finance community. And that's a particularly urgent question when we know that nearly half of primary steel capacity outside of China will reach the end of its investment cycle in the next 10 to 15 years. So we have a window of opportunity to change, but that window of opportunities could be missed if we don't have the technologies we need by then. So in that context, I'd like to turn to Asa first, if we go to the next slide. And ask you, Asa, what is your perspective in terms of what are the most promising technology solutions on the market at this stage, and what is really missing to bring those technologies to commercial stage?
Well, thank you very much, Faustine, and thank you to IRENA, of course, for organizing this panel. Well, we've already seen that there are a number of different options to produce low carbon steel in the future. In fact, you can categorize them basically in three different groups. One is to keep using carbon either as we do today or with biomass, but to prevent the emissions, of course, by using CCU or CCUS. The second one would be to use hydrogen, and that's in quite advanced stages now, in particular in Europe. And the third one, which is perhaps a bit more in the future, is to use electricity directly through electrolysis. What I want to point out as well is that these technologies seem quite sort of separate, but they can also be combined. And I think that's something that we are going to see in the coming decades, sort of before they are developed fully. As in, you could keep basically the existing facilities that you have today, so the blast furnace in particular, use more hydrogen injection directly in the blast furnace. You could also use renewables, for example, from sustainable biomass from agricultural waste, for example. You collect them, the gases afterwards, you use them to produce raw materials for the chemical sector. The CO2 you separate, you can store it. And so you can combine a number of these technologies into the same thing. Because one of the problems, or well, I shouldn't say problem, but the challenges that we have now, of course, is that the steel industry is very capital intensive. We have very long-lived assets. And many of these real breakthrough technologies that will enable us to go to zero emissions mean that you really need to change your whole production infrastructure, you could say. So depending a little bit on where you are, what the available resources are, the policy support, and so on, this is going to happen at different stages around the world, and different technologies are going to be more or less predominant in different parts. My last point would be that we are going to need all of it. This is a ginormous challenge. The steel industry is a growing sector, and we are basically going to need all the technologies that we can find, and as well all the low carbon raw materials, including, of course, storage. So I'll stop there, and yeah, I can come back to some specific points later.
Thank you, Asa. Mr. Yonghi An, can I ask you what technologies you're looking at for POSCO specifically? You obviously have a diversity of sites within the company. I'd love to hear what your perspective is on those different technology options and the type of support that you're expecting from governments to help a company like yours transition to those new technologies in the context that, as explained, that is a difficult context in terms of new investment in technologies that are yet to be fully proven at scale. Do we have an issue with Mike, with Mr. Yonghi Han? If so, I will turn to Andreas in the meantime to ask you, Andreas, what your perspective is at this stage. You're the chairman of Hybrid, and Hybrid has, as many people will know, opted for one specific technology option, which is hydrogen-based direct reduction of iron. And so I'd love to hear why you've gone after that particular technologies. How does that fit within the context in which you're operating, which is the Nordic context? And what does that imply in terms of renewable input to the production, given the importance of renewable power in producing the hydrogen for this particular technology?
Thank you, Faustine, for that question. Happy to participate and I just want to say that I saw the presentations for the context. I think was incredibly encouraging, and I think it summarizes in a very good way what ETC has been saying for some time, and now it's becoming the truth, which I think is very, very encouraging. And when it comes to our of technology, i.e. the direct reduction with hydrogen, I think it's, as pointed out in some of the material, it's key, of course, then to have access to fossil-free electricity. And we do even today have an excess, so an energy exporter or fossil-free electricity exporter in the Nordic region already as it is, particularly in Sweden. So that's one of the starting points, of course. And then another piece of the equation, which you also highlighted, is that it does matter the age of your current asset base, because it's much easier to take a step if you were to take that step anyway. So I think that's another part of the equation. And thirdly, I think Swedish industry has a long history of kind of innovation. So if you combine those three, that you have an innovative climate with a government that is very supporting, and then the fact that there were kind of assets that fit very well to taking a step. Very practically, we had some blast furnaces that were moving out of economic lifetime, and then thirdly, our good access to fossil-free electricity at a reasonably low price. So I think that is the three things that made this happen.
Thank you, Andreas. I'm going to go back to Mr. Yoon Gi-han and see whether he is with us and whether we can hear him. Hello. Could you please speak to us to double check whether we can hear you? If not, I will come back to you, Asa. You mentioned that we're still quite a way off commercialization of the different technologies that we outlined. And you also outlined the fact that there wouldn't be any silver bullet. We need all of the potential panel of technologies, and we also need to combine them. What type of supports are your members of the World Steel Association, expecting from governments to help them on that journey and to support them as they approach those new technologies?
Well, thank you. I think, as we heard from Andreas, there are certain enabling conditions that really help this transition, and I think it's very important to understand those to be able to scale it up, because they are not currently available everywhere, and they might look different, of course, in different countries and depending on which technologies you are looking for. But I think it's first of all, it's key that there is a long-term national climate policy with goals that do not change after the next election, because these are long-term projects. Even if you are making a real commitment today, it is going to likely to be at least one decade before you can actually put this into real practice. And then the partnerships, of course, with governments and other stakeholders around the resources, the infrastructure needs, be it for electricity, for hydrogen, for storage, for biomass, and so on. And also, of course, working together with other industries in kind of making sure that the produced, let's say, for example, gases from a CCU that can be used for chemical production, that these sort of, how can I say, systems are sort of put in place. For that this low carbon steel production is going to be more expensive. That as we now seen from a number of different analyses from many different organizations. And though the numbers vary, most often there is somewhere between 20 and 100%, which is significant in terms of the end user products, perhaps not so much, but definitely for a steelmaker, that might mean that their production suddenly is twice as expensive for their products. Today, steel is traded globally and sold on a global market with very high competition. The prices are set globally, which means that if your production is more expensive, it's going to be very hard for you to compete. In addition to that, the margins of the steel companies are also very, very low, which means that this often is expected to eat up the whole margin, in fact. So I think one of the really keys is to develop a market for these low carbon steel products so that they are able to, the producers, the first movers, are able to compete and survive and prove that their technologies are really useful or are really sort of beneficial. I think that's really key. Yeah.
Thank you, Azan. I will come back to that question of pricing and how to mitigate the risks in terms of carbon leakage. But before, I want to focus on this point that you just made around infrastructure and the importance of having the energy infrastructure in place to support the steel sector in that transition. Andreas, coming back to you, you come from the power sector initially. So that's
well, I'm still there, but yes.
And the key question I had for you is, how do you prepare for such a big increase in power demand, that a shift from a steel production facility to hydrogen or to indeed electrolysis in the future represents? And what does that mean for the power system in a country like the one you're operating in? How do you integrate that new load in the power system?
Thank you, and it's a very important question. And I think the answer, luckily, to the first large plant, we hope that will soon start taking the investment decision on. The electricity is already there, but as soon as you move to the second one, that won't be the case anymore, or at least that there's a need for significant infrastructure to get there. And I think that's a key question, actually, because I think that's not something that one individual player as Vattenfall or any other energy company can do. I mean, we can have views on the future price that will lead to maybe that we invest more than we otherwise would in new production, but that's not going to solve the issue. So I think what we heard here from the German minister is that there is a need to make a plan. And I think that's what countries need to do. So I believe that what Germany is doing and what I think we're beginning to hear from France and the other day Spain, that you start realizing that it is not something the market will fix. The changes that we stand in front of and the investments needed, I think the money is there, the will is there, the technology is there, but it won't happen unless we have a kind of an overall frame and plan to relate to. And I think that's something that we actually argue for quite a lot in the Swedish context. And we haven't really reached that stage yet, but I see more and more signs that now more or less everyone agrees that there is a need for a plan. It's just a question then who will do it, and I think the government has a very important role in it. I think that's a super important question, because once you see all these needs mounting and the number of terawatt hours, and I think I saw that in the plan that was presented as well, that the first point is to agree that we agree, because that's super important, and then we can then make a plan together, where I think the governments have a very central role, but also other stakeholders. Otherwise, we will not be able to answer the question that you just asked. And it's not one player that can do it, it's society, and ideally then cross nations even.
Thank you, Andreas. And as this is true for everything that is power related, obviously, but this question of infrastructure is also very important for carbon capture, especially for carbon capture and storage. I'd love to hear you on how to coordinate that infrastructure, and whether you agree with Andreas that this requires a plan from the top that is concerted with industry stakeholders, and how you see the difference between building that infrastructure in the power sector versus for carbon capture.
Well, I would agree very much that the infrastructure is definitely needed. We also need, I mean, in CCS, there's an interesting project now, of course, that I'm sure everyone is aware of in Norway, where the idea is to ship the CO2, which would allow many countries or others who are not able to connect, let's say, physically with pipelines and so on, to actually make use of this service, you could say, and also at different amounts or volumes, because that's another thing. I mean, these, as we were saying before, the breakthrough technologies in the steel industry, like the hybrid project, that's a completely new new production or a way to produce, which means a completely new installation. But many installations were not yet at that end of their lives, so that they are willing to do that change at this moment. Could use CCS for a period of time before they do the big shift. And there, of course, it's very good to have these more flexible solutions, that you don't have a pipeline which you need to, of course, submit a certain volume all the time to make it sustainable. But with the shipping infrastructure, you will be able to adjust those volumes as you go along. So what I wanted to say with that is that I think we need to be innovative in the way we think about infrastructures as well. It's not always about very physical pipelines, but different ways of achieving the same goal. Yeah.
Thank you, Asa. Let me try reach Dr. Hahn again and see whether we can now hear you, Mr. Hahn. Are you able to hear us and speak? Apparently not, unfortunately. So we'll keep trying to connect you to this discussion. In the meantime, Andreas, I wanted to come back to you and come back to a question that Asa raised a couple of minutes ago around competitiveness and the cost of transitioning to low emissions and eventually zero emission steel. Based on your own assessments, when do you expect to be able to produce zero emission steel? At what price point? And what do you think is required from governments and from your markets to help you find the market and underpin the business case for that higher cost zero carbon steel?
Yeah, many questions. I think when we do, our current plan is to have our first demo plant, which would be a quite sizable demo plant, operation by 25-26. The price point, I guess it's still a bit early to talk about. I mean, we have in the early days, we made some then preliminary conclusions saying that the price of iron sponge will be 30-40% higher than at the time cost for the normal route. However, with blast furnace. However, I think that we also at that time, and I think we updated the calculations, but maybe that's still a bit early to talk about them. But I think at the time we also said that at the CO price of 60, it's more or less break even. So of course the CO2 price plays an incredibly important role in this equation, and that comes back then to the competitiveness, because I think as we now, well, it's not finalized yet, but if/when the target for Europe is changed to 55% decarbonization until 2030, the slope of the CO2 curve must go up quite dramatically, which then likely one of the or more or less known consequences of that is the higher CO2 price. And who knows how high it comes, but it will come much closer to 60 than it is today. So I think that in itself will be a rocket starter of many initiatives beyond steel, because there are many, I think, other decarbonization efforts that start really becoming a business case if you start approaching even 50. So that's one part of the equation of making it competitive. The other part of making it competitive, I think, of course, support will be needed in the early days, but I think it's more to cover risks and technical risk and delay issues, and so because there's so many risks inherent in building something new. Because I think from a commercial perspective, I think the combination of CO2 and a transparency, so that because if you produce something with low CO2 footprint in the middle of a value chain, you need to have or your downstream customers must be able to market that benefit of the lower CO2 footprint. And I still don't think we have really the tools for that transparency, because if we want to sell to big truck or steel to a big truck manufacturer, or they need to be able to in a low cost way explain why their truck just became more climate friendly. So CO2 price support to cover the teething problems of these manufacturing plants, and then having transparency on the CO2 footprint. I think those three things together can take us far.
Thanks, Andreas. And CO2 price up is obviously a critical dimension. We can expect, as you say, the EU ETS price will go up in the near future, and it has indeed been maintained despite the COVID crisis over the past couple of months. But obviously the steel sector is one of those sectors that benefits from free allocations within the EU ETS. There's a reason for that. It's because steel is exposed to competition from outside of Europe. So one of the questions that has been raised in the Q&A, I'd like to hear Elsa on that point, and then you, Andreas, is whether border carbon adjustment, which is currently discussed at EU level, as a way of ensuring that heavy industry sectors are exposed to a carbon price while being protected from carbon leakage across regions. Is that border carbon adjustment mechanism the right solution to at least incentivize the first wave of investment in low carbon technologies in the leading regions, for instance, in Europe? Elsa, what's your point of view on the subject?
Yeah, this is a very difficult topic for us as an organization, because, well, steel is, of course, global. We have members everywhere, and this is one of the reasons why we don't get involved in trade aspects. So all I can really say about that is that it's, of course, very important that it would follow WTO rules, that it would not be seen as a form of sort of protectionism, and not, punish. Well, that it's developed in the proper way. And apart from that, I will not say anything more.
We can sense that it is a tense and difficult topic.
I could perhaps just say that of course the views there are lots of worries from outside of Europe on how this will work and what kind of impacts it will have, and how you will calculate the values on which the adjustment will be based, and so on. So until we hear, I think, more from the European Commission on what those rules might look like in the future, we can perhaps come back to this topic.
Thanks, Asa. Andreas, what's your perspective?
I think Åsa's points are essentially telling the story that I think conceptually it's a great concept. Depend a bit, coming back to the transparency point I made earlier, that unless there is an agreement what emissions are, if there had been a kind of global agreement on how to calculate emissions, I think I would have been more positive to beyond the conceptual attractiveness, but the reality attractiveness, I'm not sure, because there's so many ins and outs of calculating the CO2 emissions. Of course, I mean, I even as a European, I mean, it's not impossible that you would use those that flexibility in thinking about what CO2 emissions that could potentially favor your own industry rather than being perfect control. And that just the very suspicion about that makes the implementation very, very difficult. So I think it comes back to, and it will be a big benefit in many other aspects. So if we could agree globally on how to measure CO2, because that, if you start with that perspective, I just sense that shouldn't be overly sensitive. I mean, I think one could make some progress there, and once you have that basis, I think some of the other things becomes much easier. But if you start in a carbon tax adjustment without having any agreement on how to measure CO2 emissions, essentially, where it's the scope of value chain, there is so many things. I think it would be very difficult not to that it's perceived as a trade barrier, and if it's a trade barrier, we don't need more of. But we need something to protect European industries. I'm not saying we need to think about how to reach what we want to reach with carbon adjustment.
Thank you, Andreas. As an on that point of traceability and ensuring that CO2 emissions are measured across all regions in the same way, what's the role of the World Steel Association to get to that point? And is there a role for intergovernmental organizations as well in helping create that joint basis to observe the steel industry?
Well, what we do as World Steel is that we do collect CO2 data from our members on an installation basis. We developed our methodology. It's based on the Greenhouse Gas Protocol. Developed it in 2008. I think the first data collection was done. So it's been done annually since then. But this is essentially a tool for companies, or for sites rather, to compare themselves over time and to understand how they look in comparison to other steel plants. It does not. It's not very specific on the type of installations you have within your plant. This data collection methodology has later been the basis for an ISO standard, ISO 14444 series, which could perhaps be the basis of a global system. But it's on a site level, it's not on a company level, and it's not related to the products. So yeah, I would agree that there is still more work to be done. I know there are a number of projects actually sort of in the starting phases now. I'm sure many have heard of Comet, for example, which is trying to look at this on how you can agree on a methodology through the supply chain, because the transparency is, of course, absolutely key. Just one last point on the carbon border adjustment related to transparency. Transparency of emissions is, of course, very important, but also the transparency in the accounting of the carbon prices that companies are subject to. Because some of them are very straightforward and sort of easy to see, while others are more indirect. So it's to understand and compare what the actual carbon price that companies are facing in different countries is also an important and not so easy point to solve.
Thank you. I'm going to try one last time to get Mr. Han in the discussion. Dr. Han, can you speak to us? Can we hear you? Can you speak to us? Can we hear you?
Hello. Hello.
Yes, we have some
Can you hear me?
echo, but we'll try make it work. Could you, Mr. Han, give us on different technologies to steel decarbonization?
Hello.
Hello, can you hear us? And could you speak to POSCO's views on technology for steel decarbonization?
Yes, I'm sorry. I cannot manage this ITAP. So due to the technology problems, I cannot access that. But I'm so sorry. In the POSCO and the Korean steel industry, have tried to reduce this carbon emission, and this is the goal. Carbon neutral program.
Okay, I think we are unfortunately unable to hear you. We turn back to Andreas and Asa for the last couple of questions. There are lots of questions back on the technology that I wanted to address. So just a quick word maybe from you, Asa, on CCU as an option, and whether CCU in particular can really enable us to reach zero emissions, given that it's a reuse of the carbon rather than a complete and definitive storage of it.
Well, I would say that first of all, it can play a role in the partial decarbonization. It's sort of on the way to the real breakthrough technologies. But also, if you see it as a combination, as I mentioned in the beginning, that if you feed your blast furnace with more hydrogen than we have today, you inject hydrogen, you use, let's say, waste from biological agriculture, so that you have more biomass in it, you would still have a similar type of off-gas that you could then use. And it's not really the CO2 in the off-gas that you're using for CCU, it's more the carbon monoxide. And if you take that and you produce a raw material for the chemical industry that they could use, then you could potentially take back that, let's say, plastic, for example, to reuse it as a feedstock into the blast furnace. So in that sense, I think it does have a role to play. But in the future, I mean, in the longer term future, the number of blast furnaces are likely to be much fewer. And therefore, the system will probably have played out its part. So I think it has a role to play, let's call it on the way. But it will not, you're absolutely right. I don't think it will lead us to net zero. Just before finishing, I just wanted to let everyone know that the International Energy Agency has been working on a steel technology roadmap. It's the last or the latest publication in their roadmap series, and it's going to be launched tomorrow. So for those who are interested in iron and steel, this is going to be an interesting read. Thank you.
Thank you, Asa. And we're reaching the end of the session, so I'd like that sentence. If the objective is to bring the new wave of zero carbon technologies for steel to market before the end of the decade, what do you think governments should do as the #1 priority? There's obviously a long list, but what's the #1 priority in your mind to unlock change in the next decade? Ada and then Andreas.
Well, I think the first thing is really to understand and accept the scale of the challenge, because this is quite enormous, and it will really take a really long-term planning, serious goals that won't change, and of course, as we've talked about already, investments in infrastructure for low carbon resources. I think that's key.
Andreas?
I think also it's taking the total perspective, and I'll allow myself to look at how to get the demo of hybrid going. I think that's we look at I think there is a reasonably clear way path forward for developing the technology, etc. What we sit now with is what to put on the revenue line. So what governments can do is to create demand, and I think public procurement is an excellent tool.
Thank you, Andreas. Creating demand is obviously one of the key dimensions of the Net Zero Steel Initiative, on which we are working together with many other steel manufacturers. So looking forward to progressing that debate with you in the coming months. Thank you very much for joining us today. Sorry we couldn't hear from Dr. Han from POSCO. I hope there will be other opportunities. And I'm going to hand over to the team at IRENA. Thank you for having us today.
Thank you very much, Faustine, and our distinguished speaker. And indeed, shame we didn't manage to get Dr. An on board. You all kick off the session with an insightful discussion on ways to use renewables in iron and steel, and also all the cross-cutting issues the industry is facing, and what are the challenges and what are experience and so on from your part of the world. Thank you very much. And now we will take a very short break of 1 minute just to prepare our next panelists, but stay tuned with us to what comes next after the break. So we will deeper into experiences in innovative solutions to decarbonize cement and lime, and then chemical and petrochemical sectors. We will be back in 1 minute. Thank you. So thank you. We are back, and our next panel discussion focuses on experience and innovative approaches to decarbonize cement and lime. It is my pleasure to introduce you to our next moderator, Mr. Jim Rushworth, Industrial Policy Director from the EU Cement Association. Jim, over to you.
Thank you very much. And if you could maybe share the slides. And firstly, I'd like to welcome the other members on the panel, which is Rob van der Meer, the European Public Affairs Director of Heidelberg Cement. We also have Kiran Ananth, who's the Principal Counsellor for the Confederation of Indian Industry. And we have David Sampini, who is the Head of Global and R&D for Cemex. So, yep, if we could jump back to my presentation. As I say, thank you, IRENA, for inviting us. And just to make the people in the audience aware, in May, Cembureau, which is the European Cement Association, which represents members from the EU27, EFTA, and also other countries such as UK and Turkey, launched a 2050 roadmap, which looks at the full value chain. So this is going from cement production right the way down to construction and then finally demolition, and also considers recarbonation as well. we developed a roadmap taking us through to climate neutrality by 2050. And from the diagram there, you can see the sort of potential reduction areas where they can be made. So not only are we looking at the actual cement, clinker and cement manufacture, but we're also looking at potential savings down the value chain in terms of concrete, the use of concrete in building, and also savings related to the actual recycling of concrete and recarbonation, both in recycled concrete, but also in concrete structures themselves. At the bottom of the chart, the one you can see is the use of carbon capture and storage, and carbon capture and use, which will be a key part of the solutions to drive to climate neutrality. And typically, we expect that to be a sort of about 42% of the total reduction pathway that will follow. We can move on to the next slide. Just focusing on the clinker manufacture, which is where the majority of the CO2 emissions are actually realized. And from here, you can see that it's not quite as simple as the picture that was painted initially by Paul, in that it will take many technical pathways to actually get down to climate neutrality. And just to give you an example of these, we can use decarbonated raw materials. So this can be recycling waste lime or other, this can be air-cooled slag. This can also be recycled concrete as well into the raw materials. Biomass will be a very key area for us, and what we're talking about here is the sort of waste biomass from many industries, and already we are utilizing a large proportion of biomass in our operations. There are improvements still in thermal efficiency. There are some older plants that can be upgraded. There are also new types of cements, completely different formulations that have lower CO2 emissions. The area that is still quite innovative and at its early stages is the use of hydrogen as a fuel, possibility of electrification for calcination, and also use of plasma in terms of heating. And then finally, CCU, CCS, as I say, will be a key area. And as I'll mention on the next slide, and I think it was also mentioned before, the key area in terms of CCU and CCS is the coordination needed. So, we really need to have joined up thinking between the Commission, between member states and industry to actually get infrastructure in place, not only for CCU, CCS, but also for the additional electricity that will be needed in terms of utilizing that type of technology. So there are 4 sort of key areas in terms of policy requests. I won't go into those now. We have a question on that later for the panel, so maybe we can jump back to that slide when we ask the question. But if we move on to the next slide, what I've tried to do here on these next 2 slides is just to show you that there are already many projects planned or currently underway to look at reducing CO2 within our industry. So we have projects such as the Heidelberg project in Norway, which is looking at carbon capture and storage. We have projects in Germany and Austria looking at carbon capture and use, so converting the CO2 captured into aviation fuel or into a feedstock for plastics. We also have a completely different areas where we are looking at the possibility of using solar power to calcine raw materials, so therefore removing the energy content that's currently put into that to enable that CO2 to be removed. And not just In the cement industry, we also have projects that are looking right the way down the value chain through improvements that can be made with digitalization as an example. Moving on to the next slide. And other projects, a similar project at the top in Denmark is looking at CCU and looking at the possibility of maybe removing an existing power station, fossil fuel power station, and supplying a fuel for that from the CO2 capture from the cement factory. We also have other ways of capturing CO2 rather than the sort of membrane and the typical sort of routes that are currently being looked at. And this is where algae could be a potential solution, where the CO2 is captured by the algae, and the algae can then potentially be a biomass fuel for the future. We also have the ability through recarbonation. So CO2 is naturally absorbed by concrete structures, and we are at the moment looking at how that can be quantified at a UN level by member states. But also we have projects where we take recycled concrete, crush it, and then use a forced carbonation to actually recarbonate those materials, which makes them more durable and better as a quality aggregate. Just the sort of several pictures at the bottom of the slide show the different types of new cements and concretes that are being produced, the types of fuel firing systems that will be needed to utilize much greater quantities of waste, and especially different sizes and different types of waste. And also an example of some of the raw materials that the industry is looking at, new waste raw materials to replace existing materials. What I'll do now is I'm going to first pose a question to Rob van der Meer. And I know that he has a few slides to support his question. But what I'd like to ask him is if he could maybe give one or two examples of key projects that that Heidelberg Cement have planned to decarbonize going forward. Thank you, Rob.
Thank you, Jim. I hope you can hear me.
Yes.
And thank you, IRENA, for asking me to participate in this call. Projects in cement industry in Heidelberg Cement. The first project that I have in mind is the big demo scale CCS project in Norway. You mentioned that already, Jim. It is a carbon capture installation that we want to install in our plant in Brevik, Norway, and where the CO2 will be captured by amine absorption and transported to a geological storage field of Northern Lights in the North Sea. It's a big project, big in volume, but also big in money. It is also a project that is now having the support of the Norwegian government, and we are waiting for the final decisions in Norway to do that. That's one project, and that's a nice project, but it's carbon capture and storage, which is at one end of the portfolio of what we are doing. The other one, as an example, is working on how natural recarbonation of concrete can be stimulated in our concrete and cement plants. Concrete absorbs CO2. Is one of the issues that I want to highlight in my input. And that is a nice future, a nice characteristic of concrete. It's a natural process, and as such, it is done continuously, so it never stops in nature. And what we want to do is to try to get that process fastened, enhanced by using the right condition, temperature, pressure, CO2 concentration. And that would mean that as a result, that a significant volume of CO2 is captured from the ambient air and will be stored permanently in concrete as a waste material that can be reused in concrete as fresh product. Thank you. That was the input that I wanted to give on your questions, Jim.
All right, fine. I don't know, Rob, if you wanted to run through the slides quickly that you've prepared, if you want
It's
to
a little bit
take us
fast. So the first slide that I wanted to mention is that our goal as Heidelberg Cement, and that is the slide before, is to become carbon neutral in concrete in 2050. And that is a global goal. So it's not European specific. It's really our ambition to become carbon neutral in 2050 at global level. That brings me to the next slide. The next slide shows that what we have done in the last weeks, what we have published in the last weeks, we have strengthened our commitment to climate change abatement. And we have set new targets for 2025. So our original target for 30% reduction in 2030 has been now improved to 2025. We have put in the meantime a target for 2030 at 500 kilograms of CO2 per ton of cement dishes. And we have, of course, continued our commitment for the carbon reduction on carbon neutrality perspective for 2050. Important to stress is that this is a global approach, but it's based on a bottom-up scenario analysis of all plants in Heidelberg Cement. So it takes into account all possibilities and also the challenges that we have in all plants. And based on that, we are convinced, we are sure that we can manage this part of our part of the carbon neutrality perspective. That doesn't mean that it's everything arranged, but we know that we can do this, and all our managers, all our people are, from that bottom-up approach, very well aware of what is happening in their situation and what they have to do, what our commitment is. So it's not a top-down, meaning that my CEO says you have to do this and that, and then everyone thinks, okay, it's the CEO, so they have to follow. It's more that we start from the bottom, asking people, what can you do? Pushing that harder and harder. And that brings us to that carbon neutrality ambition commitment. Next slide. The next slide shows you that whole portfolio of measures that we have in our carbon roadmap for all plants on globe is partly based on conventional measures like use of alternative fuels, new products, clinker substitution, all that. Partly based on innovative projects with new products, low carbon products and new types of cement, partly based on carbon capture and storage and use of CO2, and partly based on natural decarbonization. You see that here in this graph. Of course, everything is indicative. We have for each plant a roadmap, but there is always a challenge in practice how that will move around in the future. CCUS is for us an important step in that process. It was also mentioned already before, also for the steel sector. This is an important topic in the cement industry, and it is an important sector in topic CCS and CCU is an important topic also for Heidelberg Cement. And that brings me to the last slide that I wanted to show, because that is about the projects that we are doing on CCU and CCS. You see that here we are working on several post-combustion with A- projects. One is the one in Norway, but we have several others running, starting up soon, even in Eastern Europe. We have combined with three other cement groups a project in Germany for a new type of process, an oxyfuel demo scale pilot plant kiln in southern Germany that will produce clinker and cements in a normal way, but with oxygen as intermediate, as a source, and not ambient air, meaning that the exhaust gases of this kiln will have much higher levels of CO2 in their concentration. One of the things that we are also doing is in leaks, and later in the second phase in Germany in the Heidelberg cement plant, together with others, including CMEX, for instance. The speaker after me is coming from CMEX. We were working on a direct separation process, which is completely different to the A- absorption, different to oxyfuel. It means that we want to have the major source of CO2 in the cement process divided from the combustion process. We are doing that in Lilac 1 in Leeks, Belgium. That's a pilot plant supported by the European Commission. And we are now starting up the work on Lilac-2, which is a much bigger installation in Germany, again supported by the European Commission, but also supported by many companies from cement and lime industry. And apart from that, we are also working on these other issues that are mentioned here on this slide. But that is, I think, lasting too long to talk all these things through. So I want to keep it short and stay here or finalize my input here, Jim. Back to you.
Thank you very much indeed, Rob. So I'd like to now hand over to David and ask him to maybe share with us a few projects that CEMEX have planned globally.
Yeah, thank you, Jim and Rob. Yes, thank you also for some of the things that you mentioned. No, I mean, I think the thing as you mentioned, Jim. I mean, there are several initiatives. I think that all across the industry we're working very hard on now, and that's the alternative raw materials like decarbonized materials. We're looking at alternative fuels. We are looking at low carbon cement. So I think overall the cement industry and including CEMEX, I mean, we're working very hard to push those initiatives to reach the targets that we set forth to reach, especially in Europe, the 55%, and worldwide, be able to reduce and reach 35% reduction in our emissions since the baseline that we have established back in the 90s. So I think that in that sense, I think the whole industry and there is doing let's say a very strong concerted effort to bring down the CO2 emissions. But as you mentioned and evidence prior in your presentation, that a lot of it has to come through carbon capture and utilization and storage. So for example, I can give two examples maybe to highlight that. One of the things that was mentioned by Jim was that looking at solar energy. I mean, specifically because we're looking at and talking about renewables. I mean, recently we just announced that we are working with a startup called Synhelion, and in this particular collaboration, I mean, we have let's say developed technology to use solar heat to actually power the whole cement production process. Now, let's say clinker production process to be specifically. So we're able to use solar heat to actually manufacture the clinker as well as to, let's say, decarbonate, let's say, the limestone. But then not only that, I mean, we're actually, capturing the process enables us to concentrate the CO2, capture it, and then use the same CO2 thanks to the technology of our partner Synhelion to actually produce fuels. So you have the production of intermediate syngas, and then from that derivative, you can actually produce different types of fuels. That's going to be important. For example, some of the things that was mentioned about the transport industry and how the transport industry can, let's say, be able to be more carbon, let's say, neutral. So in that aspect, I mean, that's an interesting project, and what is really interesting is that it's a very holistic approach. We talk a lot about capturing CO2, but one of the big challenges we have is that, once we have a lot of CO2, what are we going to do with it? And so one of the things that we're focusing on is not so much also on the capturing, but yes, that's very important. There's also thinking, okay, downstream, how are we going to actually manage the CO2? And there are solutions that are being mentioned about storing CO2 in certain places in the world, but that's not the only solution. There's got to be more creative ways to think of that, as mentioned. And I think maybe just to underline also maybe more an unusual, let's say, type of project, which has more to do with storage, because the topic is renewable energy. So, as mentioned, renewables are going down in price. And so it's more accessible, but then, you're always creating excess energy when you maybe don't necessarily need it. So I think the next big thing that we have identified to be very important is also how to store that energy and then use it when it's needed. And it so happens that also there we're partnering with another interesting startup called Energy Volt, where we're using actually our materials, so cement-based materials, but not only, but cement-based materials combined with certain, let's say, the other materials in a sustainable way. We're able to actually create the fundamental, let's say, literally building blocks of that technology. So the technology by Energy Volt, it's actually very interesting. It's basically a simulation, or let's say a representation of hydro, but in in the form of a tower. No? So what it is basically, the idea is very simple. Actually, it's actually lifting blocks of a certain weight, up to a certain height, and then of course, so when the grid is, when let's say your renewable energy source is generating energy, you use that energy to lift the blocks. So that's storing the energy, so like a battery. And then when you actually need the energy, actually you actually drop the blocks from a very high from a very high place. So it's a very simple concept, but there again, our, let's say, technology, that cement-based technology is actually used for that technology, but at the same time we're storing energy. And then of course, some of the other things that we're doing is also developing materials that are clinker free, that they don't have any clinker at all, and they actually make use of let's say other chemistries to be able to let's say substitute, let's say clinker-based materials. So that's kind of a very quick and high. Or I mean, just try to highlight a couple of things. Obviously, as Rob mentioned before, I mean, we're working also in European projects together with other cement companies, and I think I would like to mention also that the Global Cement and Concrete Association, is involving industries across the world in the cement sector. And working very hard to focus on how to mitigate CO2 emissions, how to also highlight that concrete can be a very sustainable product, and maybe people just see the materials like very gray, simple, boring material, but it has many virtues in terms of sustainability. So I'll keep it at that.
David, thank you very much for your answer. A slightly different question I'll pose to Karan is, welcome to the panel. Do we see any of these types of technologies already starting in India? And maybe if you can give some examples of what's actually happening so far.
Sure, Jim. Thank you. So I'll just talk about the kind of initiatives that is happening in the Indian cement industry. As you know, it's the second largest cement manufacturing nation today, with about 540 million tons of installed capacity. And can I get my slides up, please? I just have a few slides that I would like to share. Yeah, the next one. So one of the guiding documents that the sector took up was on the low carbon technology roadmap for the Indian cement sector. This was developed by the sector immediately after the global roadmap was released in 2009. The background was that the numbers that were looked up as a target for 2050 in the global roadmap were much higher than where the Indian cement industry was at that point in time. So there was a need that was felt for developing a country-specific roadmap, first of its kind sectoral study in any country globally. And this came out with very specific target in terms of about 45% reduction in the GHG intensity by 2050 of 2010 levels. Looked at 4 or 5 key levers, looked at alternate fuel, looked at energy efficiency, and still a large dependence on carbon capture and storage. So the CCS is still, the light blue portion of it that you see is still a vast majority of the targets that we are looking at. So there was also a kind of a yearly roadmap in terms of when we see each of these technologies coming in, and obviously the more priority or the focus was on energy efficiency, renewables, on the new types of cement, and on alternate fuel utilization. The next slide, please. So the key indicators, when we looked at it year on year, there were specific targets that looked at. I mean, energy intensity, the country was already at one of the lowest numbers globally. It was about 80 kilowatt hour per ton, but the target was to reach 70. Thermal intensity was about 725, which is roughly about 3,100 kilojoules per kilogram clinker, but the target was to reach around 2,700 kilojoules. Alternate fuel utilization was about 0.6% TSR, was to look at about 25% TSR, but there was a specific roadmap and direction for each one of them that was laid out in the low carbon roadmap. The next slide, please. So the set of graphs that you see here talk about 2 lines in each one of them. The top line was what was taken in the global roadmap. The line that you see in the bottom in almost all these slides are the numbers that are taken for the Indian roadmap. The clinker factor, for example, the global roadmap was at an average of 0.8 and was targeting 0.7. The Indian roadmap looked at 0.74 and was targeting 0.58 by 2050. And similarly, in all the numbers that you look at, be it electrical, thermal, alternate fuel utilization, the numbers that was taken by the sector was far more ambitious. For example, the thermal energy consumption, the sector's target was to reach around 800 kilocalories per kg clinker by 2050, while the Indian cement sector started with 725 and is targeting at 680 by 2050. So these kind of numbers were more specific to the country in terms of where the current scenario is and how it can lead further in terms of reducing its emissions. Next slide, please. So in terms of specific decarbonization strategies, I think all these areas were looked at. So primarily answering your question, Jim, I'll maybe restrict it to talk about energy efficiency, the resource efficiency, renewables, and the product efficiency downstream. All these have been addressed. There is a lot of effort that is happening on the thermal and electrical efficiency improvement, on alternate fuels, on alternate materials. It is just that on the carbon capture, there are just 2 pilots which have just started in the country. It is still at a very, very nascent stage, I would say. I think a couple of factors that were driving this. One is we still don't have a carbon tax, so there is no reason for industries to make that large investments at this point in time from a regulatory perspective. Second, I think one of the speakers also mentioned that what do we do with all the carbon that is captured? I mean, we still don't have a business case in terms of what will happen with the carbon that is captured and what would be the final end use of it. So I'll stop here and I'll see if you have any further questions in the interest of time and not going through the subsequent set of slides that I have.
All right, thank you very much, Karan. We have 10 more minutes, I understand, on our panel. So what I'd like to do is just pose a couple of questions to each of the panel members. So maybe if I posed a question to Rob, in terms of the route to climate neutrality, I mean, what are the sort of biggest regulatory hurdles that you see?
And that's in fact very nice that you raised this question. And this is also the question of not as such from Dolph Gielen, but he is asking, can we, is it possible to reach carbon neutrality? Yes, in 2050. Yes, it can be done in cement industry. It will be challenging. It will be challenging. I see it always from 3 elements. It will be challenging from technical part, meaning carbon capture, new products, clinker substitution, alternative fuels, alternative raw materials, natural recarbonation of concrete, all that. But that's technical. And I think that can be managed. We as cement industry, I believe that we can do that on global level. That's one. The second element is to achieve that, we need an infrastructure. We need infrastructure for CO2. What are we going to do with the CO2 was mentioned already 2 times. So where is the CO2 emitted? Where is it produced? Where it can be used? Where it can be geological storage? That means that we need an infrastructure for that. We need an infrastructure for renewable energy. The electricity has to go to the cement plants. And how do we get it there? We need an infrastructure for the waste materials that can be used in cement plants. And we need an infrastructure, for instance, for the recycled concrete that we have to reuse. All that is part of the package. The third pillar, I would say, is on the regulatory framework. We need at the end the situation that one, cement company, concrete companies are able from a financial perspective, but also from a legislative perspective to invest these amounts of money and to work on the solutions. We also have to take into account that we need a fair level playing field in the world, but also in the regions, so that the one that is having high carbon costs is not penalized compared to others that are not having the same or equal level of CO2 cost. We need, for instance, the ability to use alternative fuels. We have to have capture, storage and use being legally possible. So we have, in fact, a lot of questions and conditions to be fulfilled by society, including the governments, in order to achieve carbon neutrality in the cement sector. It is not simple, the technical perspective, what I mentioned before. That can be done. It will be a challenge. It is not easy. I don't say that we have all the solutions now already available, but we know that we can manage that as cement industry. That's one. The infrastructure, that is fundamental. Otherwise, you have cement somewhere, you have somewhere else CO2. And what are you doing? And the last part is it has to be made financially, economical, and legally possible. So that's the conditions that have to be fulfilled, Jim. Thanks.
Okay.
And it's also an answer to Dolph. Yes, it is possible.
Okay. I see we have a question related to China. I know we have heard recently the commitment by the Chinese government to get to climate neutrality by 2060, I believe. I mean, GCCA has members in China, which is the Global Cement Association, Cement and Concrete Association. So certainly I know in the industry, you know, we are not just looking at Europe, but, you know, through GCCA, we're also looking globally at how things need to move forward. And maybe if I can jump back to Kiran just very briefly, just to ask the question, what do you need in India to actually drive this process in terms of maybe investing in things like carbon capture and storage and so on, and carbon capture and use? Is it a CO2 price? Is it to have some scheme like ETS put in place?
Yes, Jim, I would say to begin with, yes, there is a need for a scheme like an ETS to come up. There is no business driver right now for a cement plant to put up a CCS technology today. While some of the Indian cement manufacturers have started looking at the pilots, they are way too expensive. One, the price of carbon is not there to begin with to be a driver. And second, we still don't have a clear infrastructure, like Rob mentioned, on what do we do with the carbon that we capture, and say what is the economic value that we derive out of it. So in terms of a commercial sense, it is way too expensive. There is no return on investment with the kind of prices that are looked at for the pilot right now. Either the driver should be a market driver or a regulatory driver.
Okay, thank you very much. Just jumping back to David, we utilize a lot of clinker replacements, clinker substitutes at the moment in our industry. Those are sourced from coal-fired power stations. They're sourced from blast furnace operations. We know that both of those will disappear or largely reduce in terms of the blast furnace. How will we be able to substitute that with other materials? What sort of ways are we looking at the moment?
Yeah. Okay. So I think those sources are going to be short, and of course the industry is already working to find alternatives. No. So for example, there's a very significant project that's, let's say, as mentioned in the GCCA, the Global Cement and Concrete Association, and in the Innovation Network, that's the Innovandi Network. I mean, it's putting a lot of emphasis, and already companies are working on what is called, like, for example, calcine clays. So there are clays that have certain, let's say, phases that, let's say, when we actually heat treat it or transform chemically these phases, they become, let's say, active materials. They become, let's say, materials that can be, let's say, partially substitute clinker. So there are those kinds of initiatives, and there's also, let's say, natural, let's say, pozzolans and natural materials that other, let's say, alternative, let's say, sources besides slag and fly ash that can be used. No, and I think then there is, I think one thing also to keep in mind is that like if more and more, let's say, of the carbon capture technology or actually starts to let's say become more prominent in the industry, of course, that means that also most of the cement that we'll be producing will, let's say, have a very, very low CO2 footprint, and also that will probably alleviate some of the requirements for substituting the clinker. So because the clinker is going to be more, let's say, less CO2 intensive. So I think things kind of go hand in hand. So I think that the faster we can move to carbon capturing and producing, let's say, cements with low CO2 footprint, also the demand on the clinker substitutes will be lower. No, but I think the industry is working on many different fronts to actually create either develop materials that can be clinker substitutes and have the, let's say, so-called chemical activity that, let's say, slag and fly ash have today that we're using as substitutes. And of course, all is driven by economics. No, it has to be viable, from a logistics, environmental, and of course, production perspective. No, that's how I see it.
Okay, thank you very much. Just, I know in the previous panel there was a discussion of some sort of carbon border mechanism, and I think that there are concerns within Europe that for this investment to take place and for the market for low carbon products to be there needs to be some sort of mechanism that ensures that that if low cost imports come into Europe, but at a higher carbon content than the products that are being sold, that there needs to be some sort of mechanism that sort of ensures that the sort of costs in Europe to drive to climate neutrality are also either replicated in terms of the cost for imports, or more importantly, as a way of encouraging other countries to go down the route of trying to decarbonize. And I think we've already heard in India that that large inroads have been made in terms of reducing CO2 emissions. And obviously, it's important, if any mechanism is introduced, that we need to ensure that if there are measures in other countries already in place, or the industry have already made significant improvements, that those are taken into account. But as mentioned by some of the previous speakers, if it is introduced, it's not going to be a very easy instrument to be able to first introduce, or even first develop. Anyway, I'd like to thank all of our panel members for their contributions. I'd like to thank IRENA once again for giving us the opportunity. And please, if you do a Google search, you will find the 2050 roadmap developed by Semburo, which is on behalf of the European cement industry. And I know that there are similar roadmaps being developed by many of the member states, and one is planned, I think, by the Global Cement Association, Cement and Concrete Association, for the near future. So thank you very much, everyone.
Thank you.
Thank you. Thanks.
Thank you, Jim, and our distinguished speakers for another fruitful discussion. A lot was covered in this session, a lot of challenges, but we know we have to do something about it, and there are solutions available. So thank you again to all. And now our next panel discussion will focus on chemical and petrochemical sectors and on experience and innovative approaches in order to decarbonize them. And it is my pleasure to introduce you to our next moderator, Dr. Deger Saygin, who is the director of Shura Energy. Apologies. Deger, over to you.
Thank you very much for the invitation, and thank you to IRENA and the organizers for this event, and also for inviting Shura Energy Transition Center, which is located in Turkey, and it is the first and only think tank of Turkey working on energy transformation issues. And in this last session of today's global industry sector transformation session, we will be focusing on the chemicals and petrochemical sector, which, as you would realize also from the ranking of today's sector debate, it is the third largest emission intensive sector within the industry, behind iron and steel and cement. But in terms of the energy use, including the uses of fossil fuels as feedstocks, it is the largest energy user in the industry. So it is, from an energy perspective, very important. And as we've seen in the introduction slide, its energy demand is only a few percentage points covered by renewables. And in terms of the demand for gas and oil, 10% of all the gas globally and 12% of all oil globally is consumed by the sector to produce chemicals and different types of plastics. However, when we look into the production processes, only about 10 processes represent around roughly 3/4 of all the sector's energy demand. So it's also characterized by few processes. However, in also terms of the output, there are hundreds of intermediates and various types of chemicals and plastics being produced. So it's a very complex sector compared to what we heard before, producing several types of iron and maybe several types of cement. This sector is realizing significant types of output, and this makes the sector quite complex. And when we look into the production processes of the sector, the energy and material flows of the sector is quite integrated. So it's a big challenge to integrate processes into these traditional processes, low carbon options, and that actually makes it also high costly sector for decarbonization. The report, which has been released by IRENA, has actually a very message for the specific sector. Reaching global zero emissions in the chemicals will require a fundamental change in the production of chemicals. And the sector is also different somewhat because this fundamental change will need to happen in the life cycle of the sector. So not just in production processes, but how we use, how we recycle these chemicals. So that makes, or that creates more questions. What was important in IRENA's report, that nearly half of the effort of decarbonization comes from renewables and renewable power integrated electrification, including green hydrogen. So that's an important outcome, I think. One would expect it's more energy efficiency or other types of solutions, but it's renewables and electrification, but also circular economy strategies. So how we deal with plastic waste, etc., and as well as cross-cutting options like carbon capture, storage, and use, which we heard for other sectors as well. Among the barriers, and I think the report also clarifies that, and we will hear more on this today, the costs and commercialization speed of new production routes are the major barriers. And to force all this change, so this narrative I'm putting as an introduction, there's a role for governments, that's clear, but it's also the industry clusters, but also the consumers who will need to provide the solution. So for this session, we have speakers from leading research organizations, private sector and sector associations. So we will hear very different opinions, and our globally recognized experts will address the barriers, opportunities, and the costs, but also discuss the solutions for this complex sector. So I would like to invite Mr. Florian Ausfelder, who is the head of energy and climate of DECEMA, as the first panelist for this last session. And I've drawn a little bit of a pessimistic picture for the sector, and maybe it's good to discuss the major barriers in the chemical and petrochemical sector as he sees from his research for Germany and for the EU. And in particular, with respect to the competition between conventional and alternative processes. That's something I think it would be good to start with this panel, and then we will move on with other issues. Florian, please.
Thank you very much, Diga, for giving me the opportunity to be on this panel. I would like to start saying that actually the best point was already made by Faustine de la Salle in case of steel, but it also applies to the chemical industry. As you mentioned already, the fact is that there are few processes which are the energy and emission intensive processes right at the beginning of the value chain. And the challenge here is to actually take over the cost that is added by going to renewable processes and be able to translate these costs along the value chain. And that is actually the major challenge, because it's not foreseeable, even for relatively high carbon dioxide prices, that the new processes will be competitive with respect to existing conventional processes. And especially in case of Europe, the challenge is that we have a series of rather old depreciated plants, which essentially run on minimal costs. We won't be building big new plants in Europe. So the competition is actually against these existing plants. This situation is slightly different in China or Saudi Arabia, where you have an expanding industry, where you can implement new processes in a growing industrial environment. So it might actually be regionally quite different in terms of how the challenge presents itself. The chemical industry, as mentioned before, doesn't really use much of renewable sources at the moment. I mean, a little bit of electricity, depending where it is sourced from, and a little bit of biomass. Also, this situation might be regionally quite different, but in case of Europe, a lot of the biomass which is used is actually imported. And if you think of all the discussions you might have with palm oil, it's probably a discussion you don't want to repeat, because there is actually quite a competition between different goals. You might think of biodiversity, you might think of protecting natural resources, which might be in danger if the chemical industry would go to a large extent to biomass. However, what we really would need is, as you mentioned, a change in our way of thinking in how our feedstock moves. Currently, the chemical industry is essentially a linear industry. It takes oil, makes its products, sells these products to the consumers. They then disappear as waste, essentially, over time. This is a very linear model. And the recycling rates in the chemical industry are very low compared to, let's say, steel industry, glass industry. And there's something we really need to work on. We have potential for industrial symbiosis. We've heard from the colleagues from the steel industry that they would have CO2, which would be welcome. But as we heard from the cement industry, we need a legal or regulatory structure that allows us to actually use CO2. As far as we do it in the moment, we could use CO2 for some of the processes. We could expand it if possible, but we don't really get the benefit from it. And as long as this is not the case, CO2 as a raw material will be difficult to introduce into the value chain. I think we will probably discuss the regulatory issues later ahead. But the main challenge is we will have a coexistence of conventional processes and new processes over the transition period to greenhouse gas neutrality. And if we can't manage to find a framework to make the new processes competitive, then we will fail, because no one in the industry will actually implement them. And this is, from my point of view, the main challenge, and CO2 pricing won't be enough to address that challenge. Thank you very much.
Thank you, Florian. I think you provided some insight on challenges and also partly solutions, maybe with a similar balance on opportunities and challenges. I would like to turn to Bobette Petersen, who is the VP Europe for LanzaTech. And I would like to learn from her, especially for new chemical companies, what are the barriers and opportunities in commercializing these new alternative processes? We didn't specify them, but in general for new processes, and making a business case for them in chemicals production. Would you be able to comment on that, please?
Sure, thank you, Degar. And thank you, IRENA, for the opportunity to participate in this panel as well. Just to frame the opportunities and barriers, at the highest level in the current environment, we're seeing the real intent to build back better at all levels of the value chain. So that's a kind of a positive note to start on. I'm going to start from the marketplace and consumers. We're seeing market demand building, increasing demand for more sustainable solutions, talking about market pull, with more discerning consumers who want to buy from ethical brands. They care about product ingredients. They want greater transparency regarding supply chains, and also a growing focus on health and wellness. So right at the market end, we're seeing a positive trend. At the next level, closest to the consumers, looking at the brands and retailers, I think you will agree that we are now seeing most of these brands and the retailers having very ambitious, but also real sustainability targets that they're working hard to meet with partners across the value chain, specifically chemical producers. So again, a second positive trend close to market. At the level of the chemical producers, at the highest level, the framework is we are looking at the levelized cost of renewable power coming down, the cost of electrolyzers that will come down in the coming years. And as we've heard all through the course of the morning, clean, green hydrogen will become available. So in this context, at the chemical producer level, there are multiple new technologies becoming available. And as has been said during the course of the morning, we'll need all of these. I don't want to say there's no one solution that will fit all. It's been said again, we need to integrate multiple solutions to reach the targets. And I'm going to highlight just one example that Florian mentioned, and that is waste to chemical pathways, where carbon from emissions is used as a resource. That's obviously an area where LanzaTech contributes, but this is something that isn't yet regulated, but we see tremendous opportunity on these new raw materials, basically waste as a resource, carbon from pollution, carbon from emissions as a raw material, and we'll need help from legislation on that side of it. This will get us away from, so an opportunity here is that this gets us away from the challenges that have been faced with renewable raw materials, with bio-based raw materials, in terms of competition with food, feed, agricultural resources, land use and water use, and effectively moves us from a linear to a circular model. Beyond the market and industry players, new legislation is driving change. We see this as an opportunity. Everyone is aware of it, the Green Deal, the Climate Action Plan, Circular Economy Plan, Plastics Waste Directive, all facilitating the move of the industry in the right direction. And public funding, as well as private funding, is becoming available for more than just research and innovation. For those of you who are aware of the ETS Innovation Fund, we're now beginning to see in Europe public funding at the level needed to scale large chemical projects forward. These are 100 million plus projects and not the research and innovation scale. So those are all the opportunities, or the key opportunities. In terms of barriers, it's kind of the mirror image there. Existing policy frameworks are heavily geared towards plant-based and bio-based solutions. Stricter regulatory and sustainability criteria for new technologies disadvantage alternative pathways in some cases. There is no regulatory framework, as we just heard from Florian, for using carbon as a raw material, as there is for fuels, which has greatly helped that side. And as was talked about by Florian as well, incumbency in the chemical sector is significant. The sector has over 100 years of incentives and benefits, installed infrastructure, low-cost feedstocks, and a fairly low-risk appetite. So you could think about this sort of as David and Goliath. The new existing pathways clearly struggling to make their way through that framework. Cost has been talked about, and let me just say a big barrier we see in the chemical industry, of course, is that the price of chemicals from these new pathways will be higher for a period of time until economies of scale have been built. And we need time and money to get to that point. Having said that there are many new funds available to scale commercially, there is still a significant need for additional funds to transition to these new pathways. And lastly, really a perception of value. There seems to be a sense that, more sustainable chemicals or green chemicals should be as cheap as or at the same price as fossil-based chemicals. So we want to move the perception of value from just cost and economic value to more of an environmental and social value going forward. So those are the key barriers and opportunities from perspective.
This was very valuable. Thank you very much. And actually, I would like to take from this last point you raised on the value and cost. And I would like to be a bit more specific now on a specific chemical, which is the methanol. And Mr. Elko Dekker, the Chief EU Representative of the Methanol Institute, is here with us as a third panelist. And I would like to elaborate a little bit on this issue with him, especially given the huge time pressure we have to transform the sector. What are the solutions he sees to reduce the high cost of these new pathways, which characterized by up to 100 and even more dollars per ton CO2 of mitigation, which will be needed to enable their commercialization. And what are the current cost gap between conventional pathways and alternative low carbon pathways? So I would like to hear that from Jarko, please.
Good morning. Thank you, Degir, and also thank you to IRENA for allowing us to present our experience in this quite challenging topic, but also I think a very relevant topic, because when we see what the various targets are for decarbonization around the world, we definitely need to speed up our effort. And actually, before answering your question, I think there's a couple of things I just wanted to raise. I'm intrigued by the word decarbonization. Without carbon, there will be no methanol, and without carbon, there are no chemicals. So in our industry, rather than talking about decarbonization, we prefer to talk about either sustainable carbon or defossilization, because we need the carbon molecule as an essential element in producing our product, and not just our product, but many, many chemicals around us. So I think in the general debate, we should be careful not to paint a picture whereby we give the impression that it is possible to maintain the current society without carbon, because we need carbon. We just need net zero carbon, which is something completely different than no carbon. But that's an aside. When we look at the methanol industry specifically, this whole discussion around sustainable methanol, renewable methanol, biomethanol, in many respects is almost like going back in time, because the old word for methanol is wood alcohol. So before we had chemical catalysts that allows us to convert natural gas to methanol, the conventional way of producing methanol was through the destructive distillation of wood. So in certain respects, talking about renewable methanol, biomethanol is almost like going back into the old way of doing things. Fortunately, we have new technologies that allow us to convert a very broad range of different feedstocks to produce renewable methanol. So just some very simple and straightforward examples. Even in the conventional way of producing methanol from natural gas, some of our members already produce a lower carbon version of methanol by actually capturing the carbon at the reformer and circulating the carbon back into the synthesis loop to increase the yield of that particular process. But when we are talking about the example of the chemical industry being linear, for example, in Rotterdam, there's a project called Waste to Chemicals, which actually takes non-recyclable waste, which includes both plastics as well as biogenic proportions, and converts that into methanol. So it's a chemical way of recycling chemicals in that sense. We have projects, for example, in Sweden, where residue streams from the paper and pulp industry are being used to produce biomethanol. And in the context of the discussion around the need for larger amounts of renewable hydrogen, and the question from the previous panel around where can we use the carbon, our industry already actually has several projects, both in Sweden as well as in Germany, where we demonstrate that we can use the CO2 from the steel industry to produce renewable methanol using hydrogen from renewable resources, whether it's wind or solar. So in that sense, there's a lot of examples what we can do in our industry. In all fairness, today, the amount of renewable methanol compared to the amount of methanol produced from fossil feedstocks is still very small. So we definitely need to scale up. And that brings me a little bit to your question, because for the industry to shift from the conventional feedstocks to alternative feedstocks, there are two challenges to be handled. As Babette mentioned, producing renewable versions of chemicals we already know today means that we are looking at a higher cost price. Depending a little bit on the type of feedstock, depending a little bit on the type of process. In some cases, the production cost gap between conventional methanol and renewable methanol is not huge, but it's still there. So if you want to be in business, you definitely need to sell your biomethanol at a cost price which is higher than conventional methanol. And when we look at certainly for greenfield situations where we start off with having to build a whole new electrolyzer, installing a carbon capture, or even direct air capture, then we're looking at cost prices which are significantly higher than they are for conventional ways of producing methanol. And for our industry, it's quite interesting to see where our product is being used both as a chemical as well as a fuel. So methanol is also being used as a fuel in passenger cars and as a marine fuel. And where typically the chemical industry still has a little bit of an attitude to ask for green for free. On the fuel side of things, there is a willingness to pay for a higher price methanol due to the fact that on the fuel side of things, we have obligations. For example, in Europe, we have the Renewable Energy Directive, which requires obligated parties, so the people that actually sell us our fuels, to make sure that the fuel contains a certain amount of renewable energy. And depending a little bit on the way that it has been implemented in the individual member states, non-compliance either means you pay a penalty. For example, in Germany, the penalty for not meeting the carbon objectives is over 400 euros per ton of CO2, going up above 600 with the implementation of the RED2. Sweden has a similar penalty system. In France, the part of the value system is managed through an excise system. So it shows that with the right policy, there is a possibility of introducing higher cost products into an existing market. Whereas in the chemical industry today, we don't have such an obligation. As Babette said, we have companies that have a voluntary approach. They would like to be the first to start using lower carbon products, but it's difficult to value that higher cost product all the way to the end consumer. So I think as an industry, as a chemical industry, we can learn from what is being done on the energy side of things.
Thank you very much for also providing a solution to this. It came back to the policy question again, even when we're talking about the costs. And returning to Florian about the point he raised, and thank you for also responding to questions, Florian. You're very fast in following the Q&A part also, and you mentioned there that CO2 is not priced and not paid at the current situation, and you mentioned also in your first intervention about this. So if I may ask two sub-questions regarding the regulation part, the structure of the regulation, how to make benefit of the CO2, but also in terms of providing solutions, that's the first. And in terms of the cost, a similar question to what I asked the Elco, what would be your suggestions for closing the cost gap?
Okay, I think what my previous speakers have mentioned is very insightful, and especially what Babette mentioned. The chemical industry, as said before, has most of the emissions and most of the energy use right at the beginning of the value chain. However, at the end of the value chain, we have a consumer who might be able to appreciate a green product. And what is actually missing is the interaction between the front part and the end part of this value chain. So, and that is something we need to implement. So we will see most likely some niche products where we can actually promote the green value, and we get a market pull from these niche products, which then will translate back to the front end. However, these things are easier said than done. So I remember a discussion between different chemical companies in Germany, where one chemical company said, okay, we would like to make a promise to all our customers to offer them clean products. And we expect you to produce our shampoo bottles from recycled materials. And the other company, which was more on the front end of the value chain, said, well, that's fair, but are you willing to pay a little bit more for it? And no, we are not willing to pay more for it. And are you aware that there's only a limited supply of recycled chemicals at the moment that we can actually use? I don't care. I want to offer that to my customer. So this is the kind of discussion we have at the moment, which is not really helpful, because we need to understand what each player along the value chain has of, let's say, interest and constraints he or she is working in. Regarding the current framework, the European emission trading system currently allows only for CCS as a way of reducing their emissions and getting that accounted for. CCU is currently not allowed, with one notable exception, which is kind of a CCS because it's a very permanent product. As long as there's no way of allowing for using CO2 as a raw material in the chemical industry, we won't be able to make use, let's say, of emissions from the steel or cement industry. What might come first is the use of, let's say, green carbon dioxide, if you want to call it like that, which I would normally not do, which comes either from biomass or from the air. However, we need to be aware that these sources won't be able to provide the amount of carbon that is currently used in the chemical industry. And therefore, we need to find a way of introducing point sources, especially in the transition period, which is maybe also one aspect I want to raise. It is very nice, and we all agree on the goal to be carbon neutral in 2050. However, every carbon emission that we can save now counts in much more than a carbon emission we saved in 2050. So we should be aiming to implement these technologies, even if they might not be completely perfect, because the perfect solutions will be expensive and will stay expensive, and we won't get anywhere if we can't start introducing some of these technologies. Thank you.
Thank you very much, Florian. And I would like to turn to Babette again. I think what you mentioned was a little bit in the first intervention. I think the waste to chemical pathway, which you outlined, is an important pathway, and that is not something which we are hearing often. And this is, as I understand, is a commercializing pathway. If I may ask you how you see the most realistic pathways that will see commercialization in the coming decades for the major chemical routes. And I have a sub-question to that, which actually came from the audience. Maybe you want to answer that also. And that is dealing with how to deal with emissions from plastic waste combustion. Maybe if you would like to respond to that, that would also be great.
Okay, so really coming back to the number of pathways, I think I was trying to emphasize before, and it's been mentioned by Florian, that there are multiple pathways. We need to use all of them. They need to move forward. As we're seeing right now in this process of submission for the Innovation Fund, the ETS Innovation Fund, which is really to scale to commercial level, to TRL 9s. We need the hydrogen, we need the electrolyzers, we need the renewable carbon, we need the bio-based and renewable. And I think the only addition I would make to what Florian said is partnerships across this value chain, because there are obstacles at each level. We find being an enabling technology, as LanzaTech is, right in the middle of this, to enable the capture of the carbon from these off gases. We have to actually connect the dots from those who need the product and who are interested, those who are at the market-facing end of things, as well as those who are at the producing end. And that's difficult to do, apart from obviously policy frameworks which can facilitate and enable. It is these partnerships across the value chain, public-private partnerships that are really going to make the difference in terms of which of these are going to be the winning pathways. I won't talk about one preferred. I don't believe that there is one path that will be successful. Again, just to say they all need to move forward and much faster than they have to date, which will require substantial amounts of funding. And as they say, may the best man win. I think here we don't want a single solution. We want to encourage these multiple solutions to move forward. What we're seeing now, is some of these companies like LanzaTech are able to move across the valley of death. That's an encouraging sign. That means move to commercial scale, within the first 10 to 15 years. In the chemical industry, it takes 10 years to develop a new polymer. Now you can shorten that time, but with or without new pathways, that there is a time element there and milestones that need to be crossed. So I hope that addresses the question of which pathways. No single pathways. All these pathways need to move forward and be financed, which we are beginning to see. More money would help. And again, we're seeing the Commission right now encouraging private financing to come into the game much earlier on, which will help, because again, there's no single source of funding for any of these substantial projects. Florian, could you reiterate the question about the plastics? I'm afraid
Yes, of course. Of course, very briefly, how to deal with emissions from plastic waste combustion. There's the incentive to reduce these through supply side measures.
Okay, well, perhaps one way of looking at that is something that we're working on, which is actually using plastics waste as a resource in terms of syngas from this waste that you can feed into the chemical process. So that is, there are different ways of addressing it. There's no one single source. This obviously is a circular economy solution. And that is what we're trying to work on. As an example, specifically, we've been working in Japan with a chemical company there to take the syngas from municipal solid waste, which is unsorted, unrecyclable waste, take the carbon from that syngas and transform that into ethanol. As Elko said, that ethanol, just like the methanol, can be used for both fuels and chemicals, and a partnership was then developed with a chemical company to transform that recycled carbon ethanol into polyolefins. So I think the answer to that is there are different ways of establishing circularity for plastics, and that's what we need to do going forward.
Excellent, thank you so much. And in the last 4 or 5 minutes, I would like to turn to Elko again. And it was interesting, you gave a hint to us in your first part of your answer. You mentioned there are actually different sectors that are consuming methanol. Of course, this could also be applying to other chemicals. Do these differences in market availability for chemicals actually provide an opportunity? And if chemical sector could make use of that? If you could also provide your views on this, that would be great.
I'm sorry, Digger, your line broke up briefly during the question, so could you just repeat?
I'm sorry. Of course. You mentioned in your first part of the answer that there are different markets for chemicals. And my question is this creating an opportunity for methanol, whether transport or the chemical industry itself? And if there's an opportunity, how can the chemical sector could make use of that?
I definitely think there is an opportunity, because it means that you become less susceptible to challenges of only one solution. It gives you the optionality of picking the right synergies between, on the one hand, chemicals as well as the fuels market or the energy market. But as I mentioned before, I also think there are interesting synergies between, for example, the cement industry, the steel industry, and the chemical industry to join hands and actually work on these projects together, because if we start compartmentalizing this challenge around reducing the amount of carbon we emit to the atmosphere, I fear that we end up in a situation where we have suboptimal solutions. So if we can figure out a way where we can, for example, take the carbon from the steel industry, use it to produce a chemical, and then allow both the chemical industry as well as the steel industry to take part credit for that carbon reduction, rather than having this rather strange discussion that, well, the chemical industry or the fuels industry in this particular example is not regulated by ETS, whereas the steel industry is ETS, so there's double dipping. That's a matter of finding the right way of accounting who can claim all or part of the carbon reduction. And on the specifically on the different applications within the chemicals market, again, yes, I see a lot of synergies, as Babette mentioned, whether it's ethanol or methanol, or for that respect, a lot of the other chemical building blocks. There is a multitude of different products we can make through these processes, and it becomes more a matter of almost applying the 80-20 rule. So let's not try and find the perfect solution for everything, but let's start taking steps in the right direction. And please, let's allow ourselves to also make some mistakes along the road. Right now, it almost feels like the industry, but also politicians, are afraid of making mistakes. I heard examples around some of the issues that were experienced in the biofuels industry, but we have to make those mistakes to know what we don't want in order to get where we do want to go.
Thank you so much, and thank you to all panelists, as also the time has ended for this session. Just to say one remark, I think we have started this session for the chemical sector specifically, how complex things are, but thanks to all inputs of our panelists, we've ended with actually quite a good recipe that includes specific solutions for different chemicals and pathways, and also on the costs and regulation angles of this. And I hope this helps IRENA and also the IRENA member countries in making new policies for decarbonizing the chemical and petrochemical sector. So thank you very much again, and have a good day.
Thanks, Deguir.
Thank you, Deguir, and our distinguished speaker, for yet another inspiring and very informative session. Thank you again very much to all of you. And this now concluding our sectorial discussions. So to close the event, please let me invite Dr. Dolf Gillen, IRENA's Innovation and Technology Center Director, who will wrap up and recap all the insights shared today by our speakers, where we are and where all this innovation can quickly bring us. Dolf, please, the floor is yours.
Yeah, thank you, Martina. I don't think that I will be able to summarize all the insights, but let me highlight a few things that I heard. First of all, thank you very much to World Economic Forum, to the keynote speakers, moderators, and panelists, and for the audience that asked questions. We've heard from three sectors: iron and steel, cement and chemicals, and petrochemicals. And in all three sectors, it's clear that there is a lot of action. And having worked on the decarbonization in these industries for some decades now, I note that the dialogue has changed markedly. And there is now a recognition that really zero carbon solutions are needed and are seriously being considered and being implemented. At the same time, we heard that industry is somewhat different from other sectors. So in a sense that it's a fairly concentrated type of energy and use and CO2 emissions in a number of hundreds or thousands of sites. That poses specific challenges, but also opportunities. there is greenfield situations and there is brownfield situations, and these can have very different solution pathways. In these sectors, energy and feedstock costs account for a big share of the total production cost. And the solutions that are at the table now, most of them will increase the production cost. So that there is a need somehow to create a market mechanism that allows to account for these higher costs. And in that context, because a lot of the sectors are competing at a regional or even a global level, there is a need to create a level playing field. I thought it was remarkable that there was some hesitation around border tax adjustment mechanisms. Some were slightly in favor, some were a little bit cautious. So maybe some more discussion is needed what the solution would look like. What came out very clearly is that there is a need to focus, to think beyond the sector. There is a need for the enabling infrastructure, sorry, be it the renewable electricity supply system, be it hydrogen pipeline systems, as also mentioned by State Secretary Feicht, and also issues around, let's say, a need for systems thinking. For example, if the cement industry doesn't have coal fly ash available anymore in the future because the power sector changes, then what will that clinker substitute look like in the future? Or if there is different sectors looking at biomass supply, is there really sufficient biomass available for the industry sector? So that's I think this infrastructure and systems thinking came out very clearly as an issue and as a need for action. We heard that there is now a lot of let's say demonstration plant level activity going on. There is confidence in the industry that a transition can happen if the infrastructure is put in place and if the enabling policy frameworks are put in place, but there is some work needed to actually make that happen. While this transition poses a challenge, it can also be an opportunity. We heard, for example, that there may be a new market for methanol, for clean or green methanol as a fuel also, which could be a new activity for the chemical and petrochemical industry to supply that. We had yesterday and the day before panels on hydrogen and on electrification, and it's clear that there would be a benefit of bringing these groups more closely together to jointly discuss the solution strategies. We heard there's a need for better accounting frameworks, for example, in terms of CO2 accounting of products. How do you account for the use of CO2 as a feedstock? And also issues around the link of the physical accounting system and the economic accounting system for carbon. And in that context, of course, the chemical and petrochemical industry mentioned that decarbonization is not the right term for them because carbon is very much needed. So there is a need for more continued dialogue between the private sector players and the governments to find the solutions. And finally, it was mentioned that we should also allow for mistakes in this process as we need to accelerate this transition. That concludes my my summary of what I heard. Thank you very much.
Thank you, Dolph, very much for a great wrap up on what has changed in the sector, what has changed in the sector in terms of the dialogue, cooperation, and solutions. I would like to also use this opportunity to, again, thanks to Anthony and the team at WEF and Mission Possible Platform for co-organizing this session with us, and we look forward to collaborating with you in near future. And again, thanks to all the distinguished speakers for fantastic discussion. And allow me to make a final announcement. So if you enjoyed today's discussion, let me then invite you to our next sessions this week. So we have each day 2 sessions. We are almost at the end, but there are still 3 coming up. So today there will be one at 4 p.m. discussing transport and renewable solution in transport. And then tomorrow we will have youth sharing with us their views and their perspective. And then in our closing session, we will summarize the whole week of discussions, reflect on main challenges and opportunities, and identify next steps. We will have also climate change champion, and UK COP26 presidency to discuss what all this means for the Paris Agreement. And then we will bring technological solutions into a broader context and discuss how policies, regulatory frameworks, and finance can help to scale up decarbonization, or maybe we should call it death, like away from fossil fuels. Anyway, like how to help challenging industry and transport sector to use more renewables. There is still time to register, so please go to innovationweek.irena.org website for the registration link. And this is all from us for today, for this session. Once again, thank you for joining us, and see you in one of our next sessions.